Welcome back to another video. Today we're doing one on independent versus mutually exclusive events. What are they? Here's a simple table to tell the difference. Mutually exclusive events are when the occurrence of one event causes the other event to not occur. And independent events is when the occurrence of one event does not affect the occurrence of the other event. Of course, they cannot be the same, and that is listed out too. Can you think of any example of mutually exclusive events? Well, here's a simple one that I like to use. Flipping a coin. Event 1 is when the coin lands with heads up, while event 2 is when the coin lands with tails up. Here's an example of a coin flip. Oh, it landed on heads. When the coin lands on head, which is event 1, the probability of the coin landing on tails, event 2, becomes 0. Thus, these two events are mutually exclusive as only one event can happen at any time. Here's an example of independent events. Flipping two coins. I don't have a lot of creativity with this. Event 1, coin 1 lands with heads up. Event 2, coin 2 lands with tails up. Let's look at an example of two coin flips happening simultaneously. Yup. Regardless if coin 1 lands with heads up, which is event 1, it does not affect whether coin 2 lands with tails up, event 2, which means that event 1 is now a condition for event 2 to happen. Thus, these two events are independent as both events can happen independently of each other. Why can they not be the same? Well, let's look at this Venn diagram. For mutually exclusive events, they're separate, while independent events has an overlap. How we can interpret this is that the probability of A and B both happening is 0, while A or B happening is just probability of A and probability of B. The probability of A given B is 0 because A cannot happen if B happens, and the other way around is true. But for independent events, the probability of A and B is the intersection between the probability of A and probability of B, so it's probability of A times probability of B. While the probability of A or B is the probability of A plus probability of B minus the intersect, because only one can happen. The probability of A given B is probability of A because B does not affect whether A happens, therefore it's just the other way around. And the same for probability of B given A. Well, that's all. Thanks for watching.